Why do we sample? Why don't we just use the population every single time? Well, let's talk about what sampling is. Sampling is the process of selecting a portion or sample of the entire population. Okay, a survey that includes every item or individual of the population is called a census. So we have a census when instead of just polling a portion of the population, we actually poll every single item of the population. So why do we sample? Samples are taken when it's either impossible or impractical to examine the entire population. Studying an entire population is impractical when the population is extremely large. Now, this is the reason why we have a U.S. Census every 10 years instead of every year. It's a very, very large undertaking that's costly and time-consuming. So, let's talk about some mathematical variables associated with samples and populations. The sample size, which is how many people or objects that are in the sample, is denoted by a lowercase n. It's the number of data values in the sample. The population size, the size of a finite population, is denoted by a capital N, the number of data values in the population. So when I say data values in the sample size data values and the population data values, these data values can represent people, they can represent objects, they can represent products, they can represent animals. It's whatever your population is made of. Reasons for sampling. Sometimes a census is impossible. Oftentimes a census is impossible. It's a very time-consuming process. The cost is high for a census. The time is long for a census. And sometimes we can be more accurate when we're working with sample data because there's less data involved. If we look at the example with the 20,000 voters and we only polled 1,500, that 1,500 is a lot smaller than the 20,000, and having smaller numbers allows for less human error, so it can actually be more accurate. Okay, sampling techniques. A simple random sample is a sample of data values selected from a population in such a way that every sample of size n has an equal probability of being selected, and every data value of the population has the same chance of being selected for the sample. So, when you consider the population and you want to create a representative sample, you want to make sure that every member of that population has an equal chance of being part of the sample. Selecting a non-representative or biased sample from a population can lead to invalid inferences about the population. So if you choose a sample that doesn't adequately represent the population, you could be drawing conclusions that are false, which is dangerous because you don't want to conclude that a particular politician will win an election if you've polled incorrectly. You have to make sure that the sample is representative. So let's look at a few of these examples in 1.3 to see if the sampling following procedures will produce a random sample. A population is all females between the ages of 17 and 35 living in New York State. So this problem is defining all females between 17 and 35 in New York as the population. So to sample, the sampling procedure is devised to select a sample of 100 female college students within New York State. So the 100 female college students within New York State is a sample of the larger population, which is all females between 17 and 35 in New York State. But is it an actual random sample? And the answer to this is no. Females aged 17 to 35 who are not in college don't have a chance of being selected. So our sample, 100 female college students, are only college students. We've left out all the women between 17 and 35 who are not in college, and therefore this is not a representative sample. Part B. The population is defined to be all people who shop at Green Acres Mall during the week before Christmas. The sampling procedure is devised to select every 25th shopper who enters the mall at one of its 10 entrances. So, will this procedure create a sample that's truly representative of the whole population? Well, we're randomly selecting every 25th shopper at one of the 10 entrances, so it's possible that a lot of students may think that this is truly representative, but in fact it's not representative. The shoppers who use a different entrance to the mall do not have a chance of being selected. So if you think about shopping malls, you know that some entrances are not equal to other entrances. Some entrances are used by people who take public transportation, maybe. Other entrances are used by people who use valet parking. Some entrances are connected to stores that maybe are high end. Maybe some entrances are connected to stores that are sports related. So if you only poll at one of the entrances, you're changing the makeup of your sample to only include people who primarily use that kind of entrance. Part C. The population is all the faculty members teaching at Nassau Community College. So we're looking at all the teachers. The sampling procedure will select a sample of 25 faculty members using the following procedure. The name of all faculty members is placed in a large drum. The drum is rotated several times before each of the 25 faculty names were selected. So let's take a look. Yes, this is going to be a representative sample. Every faculty member has an equal chance of being selected. This is the same procedure that's used in lottery games. Okay, you see a huge turning drum with the identical balls inside, each with its own number. That procedure is very, very fair, and each ball has an equal chance of coming out. So in the same process, this procedure will be representative of the whole population. And the last one, an advertising agency decides to conduct a marketing poll of people living in a New England community. Okay, so there's your population, people living in the New England community. The sampling procedure will draw a sample of people living within this community by selecting the names of people from the community telephone directory. So will selecting the names of people from the community telephone directory be truly representative of the entire population? And of course, no, because people who have an unlisted telephone number, or people who use cell phones, or people who don't even have phones at all, do not have a chance of being selected. So to create representative samples, we have to make sure everybody has an equal chance of being selected.